Okay.
Second, please. Okay, so we're doing vertical motion. First of all, I'd like to tell you that there are only two possibilities when there is an object that has, let's suppose, a starting value u, velocity, and then it is falling down, so it will keep on falling and will reach a velocity v at some point, wherever you're looking at, after, of course, some displacement of s. The reason it will increase its velocity this way, because acceleration due to gravity on Earth is always 9.81 meters per second square. Alright? So which means each second the velocity is going to increase. In case it is falling, the acceleration will stay constant. In case it is falling in without any effect of air resistance. Now, it will continue to do so unless it has hit the ground, and where it will retard. Now, the other possibility is that the object is thrown up with a velocity u, and when it reaches its maximum height, the velocity will be 0. This means that this height that we're talking about is the maximum displacement, and the reason why it is losing velocity is because the acceleration due to gravity is always acting down, and that is with 9.81 meters per second square. Now, I just want to tell you, because these are vectors and vectors have a particular direction, so if the direction of velocity is same as acceleration due to gravity, take g equals to plus 9.81 meters per second square. However, if the direction of velocity is opposite to the acceleration due to gravity, take g as minus 9.81, because then it would be retarding us against it. Is it clear, everybody? Now, keeping that in mind, let's do a question, okay? So suppose there is an object that falls, it says an object is released from rest that falls vertically downwards. The object hits the ground and rebounds vertically. So they've shown the object. It's gone down. And then in the second instance, the same object rebounds like this. All right. Now, they've given the velocities. This is 0, 10.8, this is 8.8, and because it reaches the maximum height, it will be 0. Okay, so they've given this. And they say time in contact with the ground is about 0.1 seconds. Okay, so this is the question. Now please look at it, what we need to do. So they say, number 1, calculate the total distance moved for the motion in figure 1 and figure 2 combined. Then they say displacement of object in figure 1, and then they say fourth part, sketch the graph of the whole motion. So these are the questions. Okay, now let's look at the first one. The moment I see this, I know that it's falling vertically, which means acceleration due to gravity is down. And because acceleration due to gravity in this one is, you see the velocity direction is this, so I'm just going to take it as positive 9.81 meters per second square. In this, because it is going against it, so I'm going to take 9.81 meters per second square negative. So for the first one, it says calculate the total distance moved for the motion in figure 1 and figure 2. So first of all, I'm going to do figure 1. For figure 1, I would like to, I need data SUVAT. This is what I need. The initial velocity was 0, the final was 10.8, acceleration is positive 9.81, and the time is not given. Okay. Now I want to find it. What would be the best equation to use, Ariba?
Sir, 1 minute, let me see.
Okay.
Well, 1 over 2, V minus U over T.
Are you sure?
What was the equation? I don't remember it.
3 equations. V equals to U plus
Yeah.
AT, S equals to UT plus half AT square, and 2AS equals to V square minus U square.
Yeah, one.
Okay.
The first equation.
First equation.
V is equal to U plus AT.
AT. Okay. Manahil, can you tell her why is she wrong?
Because we're not given the time period, and the first one includes the time.
Yes, so which equation should we use?
Third one.
Third one. Manahil, Ariba, we want to find displacement, and time is not given.
Yeah.
Okay.
We have to find S, so
Yeah.
we have the other values.
Yes.
Right.
So this one. So this will be 9.81. This will be S. This will be 10.8. Yeah. Minus U is going to be zeros. Yes. Reba, for some reason your voice is breaking. 10.8.
Minus 0.
Yeah. 10.8 square divided by 9.81 and divided by 2. So that's gonna be 5.9 meters, right? Is it clear, everybody? Now, for figure 2 then, it's basically asks us that we got to make the same SUVAT because we have constant acceleration. We want to find the displacement. The velocity initial is 8.8 now. Final velocity is 0. Acceleration, because it's going against it, so we're going to take minus 9.81 meters per second squared. That's what you guys need to know, and time is not given. So again, we would use the same equation, 2as equals to b square minus u square, 2 times minus 9.81, and s is going to be s. This is going to be 0 square minus 8.8 whole square. Now the reason you need to be very careful about it is because if you don't put the minus sign, actually this value will be minus 2.9.81 and s, and this will be minus 8.8 square. So if you look at it, the problem is that you won't be able to get let me move it this way because the page has page has for some reason moved. Okay, so the reason why I want you to do this is because minus and minus will cancel that, and the answer you should be expecting is 8.8 square divided by 2 divided by 9.81. So that's gonna be 3.9, like that. Okay, is it clear? So now the total distance, I should move this as well. I have written it like quite. So the total distance, because they say all total distance, and distance is just a vector, a scalar quantity, so we'll just add them up. 5.9 plus 3.9, and we would end up with I need need to add it. 9.8 meters. Is it clear, everybody? Okay, so then they say find displacement to object in figure 1. So figure 1 is just this one. So we can just write the displacement is 5.9.
Sir,
Yes. Yes, Ariba. Okay. Now the interesting part is the next one that we got to do. Now imagine. Now for this one, let's just copy this so that when we are doing it, we can see what is exactly happening, and we'll just look at it while drawing the graph. Right. Now, if you decide that okay, I'm gonna take down as positive, then everything up will be negative. So which means that this will be positive, this will be positive, this will be negative, and that's going to be negative. Is it clear, everybody? And of course the G will also be positive because G is always down. You can change the signs, that's fine, it's up to you. You can take up as positive. Now what you want to do is, for a velocity time graph, so our motion started from 0 and then it reached some point, right? So we can actually find the time. So let's try and find the time. So for this one, for figure 1, if I want to find the time, I have SUVAT. So initial velocity 0, final is 10.8, acceleration is 9.81, and time is what we're looking for. So this time, Ariba, which equation should we use? What do you say? Ariba, can you hear me? Safir?
yes, sir. Can you hear me? My internet is lagging.
Yeah, I was saying which equation should we use here?
Sir, maybe the 1 minute. Let me see. We don't have S. So maybe the second one, the S is equal to UT plus, no, V is equal to U plus AT.
Yes, very good. We're going to use V is equal to U plus AT. The final velocity was 10.8 equals to 0 plus 9.81, and time is what we need. So we're gonna divide 10.8 with 9.81. Oh my god. 9.81, and the time that we get is 1.1 seconds. So it means after 1.1 seconds, yes, Abir. Safir, you did not watch yesterday's recording then. Burhan, why do you make a straight line? Burhan, are you there?
Because the issue is constant?
Because acceleration is constant, so your gradient must show a constant value. Very good. Now, at this point, I'm going to mark this so that you guys don't get confused. Let's call this A, let's call this B, let's call this C, let's call this D. So this is A and this is B. Now, in the question they have said that the time in contact with the ground is 0.1 second. Let's keep that in mind. Manahil, can you explain what happened in figure 2 when it hit the ground?
It rebounds again?
It rebounds. Rebounding means that not only it stays, it is touching the ground for some time, which is 0.1 second, but also the direction changes. If you see, it was falling down and now it's going up, right? So the rebound is generally shown with a line. So if I add 1.1, so it will be like, okay, that would be too much. It would be like 8.8. Point this, it goes to 0, and we got to find the time for this. So let's do figure 2. Displacement is not given. Initial velocity is 8.8 in minus. Final velocity is 0. Acceleration is plus 9.81. And the time is what we need to find. So we'll use v is equal to u plus at. The final velocity is 0. This is minus 8.8. And this will be plus 9.81 times time. So time will be equal to 8.8 divided by 9.81. So let's do that. This will be 0.9 almost. So the time that it has done this is 0.9. So I'll add 0.9 to 1.2 because I want to, make the graph. 0.9 plus 1.2 is 2.1. So when it reaches 2.1, basically the line would reach 0. So this is C, this is D. Now, I want to ask Manahil. Manahil, why is the two lines that I've drawn, should they be parallel or should they have a different gradient?
Should they be parallel
or should they be not parallel because they might have a different gradient?
I think they should.
Why? This line and this line.
Because they have the same acceleration of 9.81.
Yes, and they both are like going up, which means positive. So basically, both lines in rebound must be parallel and with the same gradient. So that's what I wanted to explain. Who did not understand how I drew this graph? Please let me know.
I understood. Can you just explain what the dotted lines mean? The one between 1.1 and 1.2.
Basically, this dotted line is just to show that b is at 1.1. But the dotted line that I've drawn here, oh my god, the dotted line that I drew here basically shows you that this is the amount of time of contact with the ground, and while that is happening, the direction of the object is changing. Do you understand? Okay. So, any questions now? Anything you want to ask? So in case they ask you to draw a graph of either velocity, acceleration, or speed, you got to. Okay. Now let's do some questions from the exam papers. Manahil, have you seen the scalar vector recording yet?
No, I'll do it some point this week.
Okay, I want you to basically do it as soon as possible, okay? Because the next thing that we're going to do, it will be hard for you to basically grasp if you don't watch it. Okay. Just hold on a second, please. posting the question. Hold on. In about 4 minutes, okay? About 4 minutes. Please rejoin the class when it ends. Okay, let's look at the questions now. So for the very first question, it says a swimmer swims 100-meter race. A simplified displacement time graph for a swimmer is shown. It says draw a corresponding velocity time graph for the motion of the swimmer on the axis below. Now this is a displacement time and they've given like the axis below like this. Can somebody tell me please that how to find velocity from this graph? Any ideas?
Look at the gradient.
You look at the gradient. Very good. So we got to find.
This is with my graph and
Yeah. Go on.
never mind, sir.
Okay. So basically, you look at the gradient. Now, to find the gradient, let's zoom in. We just take the average for it, like from this point. So at this point, I think it is 45. And with that said, this is 0. At 45, it has reached 50. This is 0. To find the gradient, in the first section, we got to do 50 minus 0 divided by 45. So the velocity that basically is constant really. So 50 minus 0 divided by 45 would give us 1.1 meters per second, right? For the next one, it goes to 90, and that's the same, so it would be minus 1.1 meters per second. Everybody agrees, right? So to draw a particular graph, you got to show that here, okay, or is placed below. So till 45, right here, let's take this as 0.5 and then 1.0, and this says minus 0.5 and minus 1.0. So this would mean that it would be 1, 2, 3, 4, 5 boxes. So this will be 1.2, 1.3, 1. No, 1.2, 4, 6, 8. No, sorry. This will be 1.1, right? And this will be 1.1. So what you're gonna do till 45? You're gonna go right here and make a constant line because the velocity was constant. And then this to 90, you got to make a straight line, and because there is a shift in the direction, it means you just need to draw a dotted line to show, okay, not here, exactly in the middle. You need to show a dotted line that shows basically that it is shifted to this. Is it clear, everybody? Okay. Is there any question, anybody? Anything you want to ask that you didn't understand in this?
Sir,
Yes.
when do we draw a dotted line?
To show that the direction has shifted.
Okay.
So
So
it
it's only
means,
for shifts in direction.
yeah. Just like we've drawn it here, right? We show the shift like this. The reason, why I wanted to basically tell you is basically we've done it a simplified way, although it should be like drawn from. Basically, this is the time of contact, right? This is the time of contact. Like we should have taken it here. In fact, I think this should be drawn from, wait a second. So time in contact is basically here. It's 1 second, 1 second. So this is the time of contact. I didn't take it that way. But even if you take it this way, like this is 42, right? Then basically you can draw a line like this, then, like this. That means that it is in contact. It means the swimmer would have gone this way, and then he has rebounded or pushed him to the other side. So now he's traveling in this direction. Do you understand?
Yeah, I get it.
Yeah. So the real line, if it will not simplify it, it would be somewhere like this, which means that basically this is the time that he is taking to change his direction. That's fine. Okay. Now, the next one is about the same way we did it. Now, in this question, it says the ball is passing already at A is this. So, this is the initial velocity. The final velocity is not given. They have given the displacement. Final is not known. In here, the initial velocity is not known, but the final is 0 because it reaches the maximum height. So, we know this. Now it says calculate the speed of the ball as it hits the ground. The acceleration due to gravity is always down, so we're going to take it as positive because I'm taking this as positive, which means I will write SUV AT. And now the displacement is 5, initial velocity is 8.4, final is not given, the displacement acceleration is 9.81 meters per second square, and the time is do we have time? Interesting, they haven't even given the time, you know. Time is not there. Why? Oh, sorry, we need to find this actually, right? So the best equation would be 2as equals to v square minus u square. So 2 times 9.81, displacement is 5.0, final velocity is what we need, and this is 8.4 whole square. So let's try and do it. 2 times 9.81 times 5.0 plus 8.4 whole squared, and then under root of the answer is going to be 13, right? Two significant figures. Then say show that the time taken for the ball to reach is this, and now we can simply, you know, either we can use v is equal to u plus at or s equals to ut plus half at square, whatever you want, it's fine. So this is 13, this is 8.4, this is 9.81, and I want to find the time. So the time is gonna be 13 minus 9.81. Oh, sorry, 13 minus 8.4, and then divide by 9.81. So this is 0.468, which is approximately equal to 0.47 seconds shown. Understood? Now the ball rebounds vertically with a speed of 4.2 meters per second as it leaves the ground. The time of the ball is contact with the ground is 20 milliseconds, which basically means that, right, and it says you should, you know, continue the graph it rebounded. So basically we have to draw the full graph for this one. We don't know what is h, right? Let me see. Oh yeah, he has said that it rebounds with a velocity of 4.2. If we take this side as positive and this side as negative, then this will be negative, right? And h, do they say we have to find h? I don't know. Okay, doesn't really matter. Fine. So first of all, we would like to know what exactly is the time that it reaches the maximum height. We're going to use SUVAT. The displacement is h. The initial velocity was minus 4.8. 4.2, sorry. I wrote, yeah, 4.2. The final velocity is 0. Acceleration now would be, basically it's the same. And the time, we got to find this. So the best way it would be v is equal to u plus at. This is 0, this is minus 4.2 plus 9.8, and that's t. So that would mean that the time taken is 4.2 divided by 9.8. So basically it started with initial velocity of 8.4. So what you're going to do is that what we can do is we can start with 0, and we can write here 4.0, and then 8.0, and then 12.0, and then 16.0. I'll tell you the reason why we need to do this. And these are all negatives. Now, the total time that basically the time it reaches the ground is 4.7, right? So which would mean actually we need to sort of take this side. If I take this as 0.5 and then this as 1, so I would be able to cover the whole graph. So let's try this. So for 0.47 seconds, it has gone from 8.4 to 13. So at 0, it was at 8.4. So this basically how to know exactly what basically one division says. What I'm going to do is I'm going to divide this with the number of divisions. This is going to be 4 by 5. 4 by 5, I believe, is 0.8. So this is 8.8 then. So exactly in the middle, right here. I'm gonna go to 0.47. This is the starting value, so 0. And after 0.47, it has reached 13. So let's try that. Wait a second, please. So this would mean there are 5. Oh, these are basically 5 boxes. Yeah, okay. 5, 10, 15, 20, and 25 boxes. So what we have to divide is 0.5 with 25 boxes. We know what exactly one box shows. So basically, this will be 0.1, 0.2, 0.3, 0.4, and 0.42, 0.4, 0.42, 0.44, 0.46, and 0.48. So we want to go here, right? And this should go till 13. And here we have 0.8. So it will be 12.8, and then 12.8 plus 0.8 is 13.6. So this is 13.6. So 13.6 would mean somewhere in the middle. And now here I want to go right to this point, and I got to make a line like this. Now the line is not starting from 0. The reason is that the initial velocity was basically 8.4, so you have to be careful about that. 4.2, this is 4.8, so we are almost here. And till here we are gonna just point it, and then you gotta make a dotted line that shows its rebound. And then in the next 4.3 seconds, so this will be, if I add 0.5 plus 0.43, this is 0.93. So this is 0.6, 7, 8, 9. 0.93, 92, and 93 would be here. So it means this line will then go straight till this point. Do you guys understand this? Please let me know. So this way your line should be parallel, and they should basically show the same values. And the working, basically this is why we need to draw it for 3 marks, because it takes some work. Any questions now? Manahil, Ariba, Zafir, Burhan?
No questions, sir.
Okay, everything is clear, right? So I hope that now you will be able to draw graphs like this. So now we will be meeting around, I think, next week. So we need to do a worksheet. So I'm going to send you a worksheet right now. So let's